This is a Pi computer project that displays the time in Roman numerals on a liquid crystal display. This is our third video on the Pi computer projects. If you've not done a Pi project before, I advise you to go and pick one of the other two videos and do those first. From the previous videos, we discussed breadboarding and connections to the computer, and writing and executing Python programs, and lighting LEDs. All these clocks are displaying the time of 8:29, so you can see the difference. This video is going to make a LCD display the Roman numeral time. This is an example of your finished clock. Can you understand the time? The time displayed is 17 hours, 10 minutes, and 14 seconds. You agree? Other parts you're going to need for this project: a breadboard, it's 2 by 3 inches, a LCD, it's 2 rows by 16 characters, 8 jumper cables with a male on one end and a female on the other, 7 connectors with a male on one end and a male on the other, 1 10K resistor, 1 10K potentiometer, and an internet connection to get the time. All the parts you need you can buy from mcmelectronics.com on the internet. We're going to be talking about 3 things. First, characters in a variable. To have Roman numerals, we need to have characters, and so we're going to be building a group of characters in a variable that we're later going to send to an LCD. Then we're going to be talking about using a subprogram to control our LCD. And then we're going to be talking about functions that convert a number and change it into a Roman number character string. There are different ways to build a variable with characters inside it. And we start with an empty variable. And so we can say variable name S is equal to quote quote. And that makes a empty variable to start with. And then maybe you want to put into that variable S the letters L and X. And so you can say variable name S is equal to quote L X quote. And then maybe you want to use concatenation to make the same thing. So you can say variable name S is equal to quote L quote plus sign quote X quote. Another way is to use the string str string function and say variable name S is equal to str paren, the number 5, close paren, and that will put inside the S variable the character for 5. We're going to be using in our program the concatenation to build our Roman numerals. And so this last example, we're going to take what is in the variable S and make it equal to the current value of S, and then we're going to concatenate one more character. In this example, the letter I. And so you have S is equal to S, concatenate, quote, I, quote. These are some example Roman numerals, but I want you to look at the last row. In Roman numerals, if the following character is smaller, then you add the value. But if the following character is greater, you subtract the value. So, like example, we have LIX. L is 50. And then we have a I, and that's the number 1. But the following character is an X, whose value is 10. 10 is higher than 1, so we're going to need to subtract the 1 and then add the 10. So 50 minus 1 plus 10 is 59. These are the 3 groups of subprogram calls we're going to be using to control the LCD. Now at the start of our program, we're going to send 2 commands to initialize the LCD, and those 2 are shown right here. And then the next 2 are used to control and send the first row to the LCD, and then the last 2 are used to send the second row to the LCD. Notice the number 2 in the last and the fourth command, and that tells the LCD we want the line to be centered on that row on the LCD. In the computer, each character is 8 bits wide, but we only have 4-bit path to the LCD. And so we need to break our character into 2 groups of 4. And then we're going to send 4 bits and then another 4 bits. So to start with, we take the first 4 bits and we copy those and put them on the 4 GPIO pins. That is our data path. And then on a 5th pin, we turn it on and then we turn it off. And that makes a strobe signal to the LCD. When it sees that pulse, it copies the data into the LCD. We'll be do that twice. First for the first 4 pins, and then for the second 4 pins. This is the first part of our program, and all these segments are going to be shown at the end of the video full screen, so it's going to be easy for you
you to read, but for now, they're small. We're going to start with the calling the sub-programs that we're going to be using, like time and the sub-program to control the GPIO pins. And then we start with the variables we're going to be using, and they name the GPIO pins that control the data and the strobe and the control to the LCD. The second page of our program defines the variables we're going to be using for the subprogram, and they're all documented there. And I want to talk about the MULT, the multi-variable. When I got this subprogram, it worked for the number 1, but as I changed my Raspberry Pi and I changed my program, it quit working, and funny things would appear on the LCD, so I needed to change it to 8. So if 1 or 8 not work for you, then try something else. This is the start of the subprogram that controls the LCD. All of it is just comments. So you can see that the hash tag that's in the first column means that it's only for comments. If you want to take the easy way out, just skip over them and not even type them in. They're not needed, but for clarity, so you can understand what's happening.
These are 2 of the subroutines, and then one is to enable, and the other is to initialize or start the LCD. This program takes the first 4 bits of a character in the computer and turns on the GPIO pins to show that value. Then the strobe signal is sent to the LCD to pull that data into the LCD. This program picks up the last 4 bits of the character and then turns on the GPIO pins to show that to the LCD. Then the strobe is sent to pull that data into the LCD. These 2 sub-programs, one sends the strobe signal to the LCD. You can see that it waits and then it turns on the GPIO pin, and then it waits and then it turns off the strobe pin, and then it waits a little bit longer, and then it's done. The other sub-program checks to see if the user wanted justification. And it can be either left or right or centered, and it takes that information and passes that on to the LCD. And then it takes each character in the character string and sends them through a 4-command, 1 character at a time that's sent out. The last subprogram just clears the LCD so it's ready to receive the data. Let's explain the Roman numeral function. It starts with checking to see if the number in a variable n is a 0. And if it is, then we're going to concatenate a dash in the response. And then it's going to check to see if our number is greater than 49. If it is, then we're going to concatenate the letter L and subtract 50 from the number. Then we're going to check to see if the number is greater than 39. If that's the case, we're going to concatenate an XL and subtract 40 from the number. Then we're going to check to see if the number is greater than 9. If it is, we're going to concatenate 1x, and then we're going to subtract 10 from the number and do that again and again and again. We may add 3 x's. Then we're going to check to see if our number is equal to 9. And if it is, we're going to concatenate a ix to the character variable. And then we're going to check to see if the number is greater than 4. If it is, we're going to concatenate a v and subtract 5 from the number. And then we're going to check to see if the number is equal to 4. If it is, we're going to concatenate an IV, and we're going to subtract 4 from the number. And then we're going to check to see if the number is greater than 0. And if that's the case, we're going to concatenate an I and subtract 1 from the number. And we're going to keep doing that until the number is 0. And then we're going to return the variable RR to the main program. Now that we've done all the subprograms and our Roman numeral conversion function, our main program is pretty easy. The only thing different, you'll see that at the very top I've got a try try, and at the bottom there's a except commands. And the reason they're there is that's going to let you press the Control C on your keyboard, and that will stop your program from executing. And so you can then make changes to your program and try again. Let's discuss the main program. It starts collecting the seconds for the time subroutines, and if it's different, then it collects the hour and the minutes, and then it converts them to Roman numerals and sends them to the LCD. It also displays them on your monitor to help you with fixing your program. This is a wiring picture, and you can see that I have plugged the LCD right into the breadboard and make it easier to wire.
This is a wiring list, so you can just check off each one as you install them, and that way you should not miss anything. And then notice there's a potentiometer, which is a resistor that is variable. It can change back and forth, and that changes the lighting behind the Roman numerals on the LCD. And then there's also a 1 resistor that is needed as well.
There are 2 other videos that we've made. The first is a traffic light intersection with yellow and green and red lights, and that's a fun project. And then there's also a binary clock that uses LEDs to show the time, and both use the same wiring. You only need to change the color of the lights, and you have all the wiring finished.
I hope you learned something from this project, and would appreciate your email comments to the address shown here. Have a good day.